Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions today. Co-hosting with me today is David Charbonneau.
Hi, I'm David Charbonneau, and I'm really excited to be co-hosting again for this episode of Open Source Directions. I lead development of open teams, and I'm based in Durham, North Carolina.
And our special guest today, talking about SciKit-Learn, is Andreas Mueller. Andreas?
Hey, I'm Andreas. I'm at Columbia University in New York, and yeah, I work on SciKit-Learn.
Excellent. Well, we're super excited to have you today. And before we dive into all the fun parts about SciKit-Learn and the roadmap, we're going to do our Tweet of the Week section, where each of our panelists gets to present a tweet that they've been enjoying recently. And Andreas, you're first up. So.
All right, so I'm going to be shamelessly self-promoting here and say my favorite tweet is my tweet about my pet peeve. VS Code has some issues with indenting Python code, and I think it would be really great if VS Code could actually indent Python code correctly. And so I tweeted about an issue on the VS Code issue tracker that you can upvote if you want proper indentation in Python.
Yeah, be sure to go and do that.
Yeah,
everybody. David?
Yeah, there was a tweet earlier in the week about a paper that was recently published. So it was a blog article about the paper called CoData in Action. And I just find the concept really, really interesting, where you look at data as a category from category theory, you turn the arrows around and you end up with something that looks a bit like an object. So that mathematical transformation between looking at things as data versus looking at them as objects with messages is really, really intriguing.
Well, thanks, David. So for my tweet, Serafina Nance tweets something especially poignant for this particular episode. She says, "I've taken 20 plus years of physics and astronomy courses. 2 of my professors were women. 1 was a woman of color. 1. All of my girlfriends in physics experienced some form of harassment from their male professors. Every single one. Several of them quit. Representation matters." So I think that's an important point to make, or to reinforce again this episode. So now that we've completed our personalization section, we're going to get on to a brief project introduction. So SciKit-Learn is a Python machine learning library. It's got about 35,000 stars on GitHub, which is very impressive. And we're just going to go through and ask some questions of you, Andreas, and it'll be kind of casual, and you know, we'll learn more about SciKit-Learn in the process. So
cool.
Andreas, why was this project started, and what need does it fill?
So the project in the form it is today was started by a group at INRIA in Paris that's doing neuroimaging research. And they are looking for a machine learning tool for their neuroimaging research, but they also wanted to build a tool that's more generally applicable. So they didn't want to build something that was just for their niche, but because a lot of people had similar needs in the scientific community, they wanted to build a machine learning tool that's easy to use for scientists from many different disciplines.
Awesome. So are there other alternatives to SciKit-Learn out there? Like, what's the landscape look like?
So it depends a little bit on what exactly you're looking for. And also, in particular, if you're working on Python, in the last couple of years, SciKit-Learn is really sort of the standard. When SciKit-Learn started out, a lot of people were also using theirs, I think, MLVPy, and there's Shogun. Shogun is still a great library if you're looking more for kernel machines. It's a C++ library with wrappers for Python and R and maybe MATLAB even. And there's Orange, which is also a Python library. It has a user interface. I haven't seen that used much recently, but it started actually a little bit earlier than SciKit-Learn and had a lot of features early on. Honestly, I'm not a big fan of doing user interfaces for machine learning, and I think that's the reason they had a bigger emphasis on user interfaces, and I'm not sure that is the right way to go. And obviously now there's the programming language, which is a whole programming language and ecosystem for data analysis, including machine learning. So that's a much, much broader scope than what we have in SciKit-Learn. So you can't really compare a package with a programming language, though some people do. In R, there's particular two projects that are sort of similar to SciKit-Learn, MLR and Carrot. These are both collections of machine learning algorithms together with tools for doing model selection evaluation. So Carrot and MLR are sort of similar to SciKit-Learn, though they both wrap other algorithms from the R ecosystem, while SciKit-Learn basically implements everything from scratch except for support vector machines.
What is the? Go ahead. I'm sorry.
Maybe what I should also mention is sort of deep learning. Scikit-Learn is not really a deep learning library, and we don't really do deep learning. But if people think about machine learning these days, it's often about deep learning. And so there's obviously libraries like TensorFlow, Keras, PyTorch, Chainer, MXNet. And if you want to do deep learning, you should pick one of these and not Scikit-Learn. So these are sort of different parts of the space, but definitely related.
So what technology is SciKit-Learn built on?
So most of the algorithms are implemented in Python, and we use a lot NumPy, which uses some BLAST. So basically, it's like all numeric computations written in Fortran many years ago by someone else. We also use some of the algorithms in SciPy for optimization like LBFGS, but most of the stuff is implemented in Python or using matrix operations in NumPy.
Excellent. And who started the SciKit-Learn project originally?
So, like very originally, it was I'm probably going to butcher his name, David Kurnapo, who did a Google Summer of Code project that was sort of the first thing that was called SciKit-Learn. But I think the people at INRIA rewrote a bunch of that. So that when they really started the project, there was Gaël Varocco, Olivier Grisel, Alex Granfort, Bertrand Trion, probably butchering all their names. Yeah, so that was the lab at INRIA that really sort of started fleshing this out. Oh, and of course, Fabian Pietragosa, who was master students of theirs at the time, he wrote a lot of the initial code.
Well, who maintains the project now in JS?
I think the most active person. So it's a very distributed project. It's very community focused. The most active person in the last 3-4 years is Joel Nothman, who's at the University of Sydney, and so he just showed up one day at the project online and has become very, very involved. And now he's been like basically the de facto maintainer for the last couple of years. There's other people that are very active. Adrian, who's in Berlin, and in my team, there's Nicholas and Thomas, and then there's of course still a team at INRIA with I think Guillaume, Joris, and Olivier are the most active people there right now. So I was sort of release manager / maintainer for a couple of years, but recently I'm more in the PI mode, so I don't do a lot of the day-to-day stuff. But Joel is, I think, the person that's been most consistently active.
Excellent. And so where are your users of SciKit-Learn coming from, and where do the contributors come from as well?
So it's very, like, as you might know with open source projects, we have no really idea who the users are in a sense. We see people that show up on the issue tracker, but that might not really reflect who the users are. We can also look at people at Stack Overflow, or if people teach classes with SciKit-Learn, we know these are the users. But there's probably a lot of people in companies that are users, and we have no visibility because they're probably not encouraged to say that they're using SciKit-Learn. There's a large part of the scientific communities. So there's, I forgot how many citations we have. We get like lots of citations. We get several citations every day. And so there's a very large scientific community. That was the original community that SciKit-Learn was aimed at, but now it's also, there's a lot of industry adoption. And I think it's pretty global. in terms of contributors, it used to be also mostly in academia, but now, as I said, it's very distributed in a sense, and it's still a lot of students because students have time. And
Right.
so, I mean, I got involved kind of slacking off during my PhD, and that's how many people kind of get involved. And we see a lot of people from India contributing, a couple of people from China, Europe, and US are sort of the main places. And Joel Northman, who is the only person in Australia but does more than all the other continents together.
Very cool. Is the project participating in any diversity and inclusion efforts?
Yeah, so that's actually something that I care a lot about, and actually it's pretty bad in terms of diversity right now. So basically all the contributors are either white men or Indian men, and so in particular, the core developers, I think there's one female core developer, which is Snell Varoko, who is the sister of the project creator. And so in terms of getting a more diverse community, that's not great. So one thing that I've been involved in is a collaboration with the Women in Machine Learning and Data Science. And so this is a woman-focused group, and we do we have done yearly SciKit-Learn sprints in New York to get more female contributors. And this year, we will do multiple sprints. Actually, one will be in San Francisco, co-located with ODSC West. And one will be, I think, in June in Nairobi, where Adrian will come from Berlin and host a sprint. And so that will give us hopefully, or bring in more people from a more diverse community.
Fantastic.
That's awesome. Yeah, that's a lot of effort. So at this point, we get to see the fun part of the episode. So I believe you have a couple of demos here of SciKit-Learn that you want to show off.
Yeah, I do. Let me see if I can find them and I can figure out how to share my screen. So
yeah, this is
we're sharing on the screen underneath your image. Yeah.
Just got to find the right window, right? So
yeah, exactly.
Probably have 40
All
minutes.
right.
There we go.
Excellent.
Cool. Oh no, I should have cleared that. Cool. So I'm going to run through. That didn't work, did it? Oh, there. Everything is slow. Great. So I want to run through two examples. One is sort of the Hello World example with SciKit-Learn, and the other one will be, as it says, a more realistic use case. So both of these will be supervised machine learning. So we'll have, I think for both, it's a classification task. So the first one is a small toy data set that I load from a CSV file here. So I import like my pandas, matplotlib, and NumPy, and with pandas, I write a CSV file of this wine data set. And this wine data set has several columns that show different properties of the wine, like the alcohol and the chemical makeup. And there are several quality classes, 1, 2, and 3. And this data set is pretty small. There's 178 samples, and there's 14 columns. One of them is the class, it's the quality class 1, 2, 3. And the other ones are all these properties of the wine. So in SciKit-Learn, the main data structure is NumPy arrays, and we always have a NumPy array that has the what we call features, we might call independent variables or predictors. So the things that describe the data here, these are all the properties of the wine, and we put them in what we call the capital X, the features, and we have lowercase y, which is the targets, or in this case, the class labels. So if we start with a pandas data frame, we'll basically we need to separate these two. And here I take the class and put it into Y, and I take everything but the class and put it into X. So X is now a pandas data frame with all of these columns, and Y is a series. So here I'm using pandas still. SciKit-Learn right now supports pandas as input, but basically ignores all the pandas parts and just converts it to a NumPy array. And when we talk about roadmap, we'll go into much more detail about that. But so right now I have this X and Y. They're pandas data frames, but I could just call np.array on them, and to SciKit-Learn would basically be the same. So for supervised learning tasks, we usually start off by splitting our data set into training and a test part. So the training part is for building a model, and for often also for comparing the model, and the test part is to do a final evaluation to say how good the model is. And so here I'm using the train test split function. That's a pretty trivial function, but it's so commonly used that we have a helper in SciKit-Learn for this. This allows us to consistently split both the data and the targets. It shuffles the data, and the stratify equal to Y also makes sure that the distribution over classes stays the same in the training and test set.
Excellent.
Wow. This is not supposed to take any time, so I'm not sure what's happening with my laptop right now.
You're burning all those CPU time on the webinar, it seems like.
Yeah, I think so. The webinar is taking all my CPU. So a very simple machine learning model that we can use is a decision tree classifier. So this builds a binary tree that tries to use basically in each node a single feature and a single threshold on the feature to decide what class you want to classify a point. So I built a decision tree classifier here. So in SciKit-Learn, all the models are Python classes. We instantiate the class. We now have this tree object. And the methods of this tree object are really what do the learning and the prediction. So all models in SciKit-Learn have this fit method. The fit method always gets the data, and for supervised algorithms, also the targets. And if I call this fit method, it'll return the trained tree. So actually fit modifies this tree object in place, and so this tree object stores the tree.
Seems like a very consistent API.
That's what we try to go for. I think we mostly achieved it. Actually, there's like one of the things that I spend a lot of time on is like we have tests that test everything and make sure everything is consistent. And yeah, that's one of the parts of the project that I was quite a bit involved in. So one of the things you can see here is something that I really don't like or didn't like, which is, so this is the representation of the decision tree. And so as you might know, in like by convention, this should be a string that allows you to recreate the object, right? Or at least that's sort of good practice in Python.
Right.
But we show all the default parameters here. So what I did to construct the object was this, and what I get back is this like very long thing. And one thing that Nicholas from my team added in the last release, which is out now, is an option to only print the things that are changed. And so I think that's much nicer, because if you get like and the tree is not even that bad, but there's things that have many options, and if you get overwhelmed by these huge strings, it's very hard to see what's going on. So I like to have this thing that allows you to only show you the relevant parts.
That's pretty neat.
Cool. Okay, so we built this tree object, and now we can use it either to predict with the predict method, or we can use score to see how well it performs. So here I call this on the training set, and we see on the training set it performs 98% accurate, or 98.5. So usually before you apply this to the test set, usually you want to do cross-validation on the training set. If you want to do any model comparisons to the parameters, see like, is this maximally if node equals to 5 actually good? So here I'm using cross-validate to do cross-validation, and tells me that if I do cross-validation on the training set, I get 90% accuracy. So here, one thing is that I'm on master. We just changed default from 3-fold cross-validation to 5-fold cross-validation everywhere. So if you use 0.21, it will be 3-fold by default and warn you. And in the next release, we'll use 5-fold everywhere. So I'm throwing in, like in this Hello World example, I am throwing in a couple of the things that we are just changing or just improved. Cool. And so if I do apply it on a test set, we get 93% accuracy. So that's a pretty decent model on a test set. Another thing that we worked on recently, and that's included in the last release, is nicer tree plotting. We used to have plotting for the decision trees that was based on GraphWiz. GraphWiz is a great library, but unfortunately very hard to compile and install.
It's true.
Yeah. And so I re-implemented this in matplotlib. And so if you want to, there's now this method called plot tree that uses matplotlib to visualize a tree. And so here you can see this beautiful decision tree where you can see that the most informative, or the thing that it splits on first, is the alcohol contents, and then the what is it called, flavonoids, and these two together already basically classify most of the samples into one of the three classes.
Neat. Is that a plotting?
Interesting.
The matplotlib plotting tool or tree plotter? Is that independent, or is that part of SciKit-Learn itself?
Oh, that's part of SciKit-Learn.
Gotcha.
I imported it here from the tree model. So basically, I mean, there was an implementation of a layout of a binary tree layouting algorithm called oh my god, Tilford Buchheim, maybe. And I tweaked it a little bit and made it work with matplotlib, and so we packaged that.
Very
so
cool.
Tree, yeah. And tree visualization they're very useful if you have small trees. If you have bigger trees, they're not that useful, but they're also really nice didactic because this is like a simple model that you can look at and you can understand what's going on.
Yeah. It's very helpful to learn in the learning process, I believe. So
yeah.
David, did you have any questions before we wrap up this demo? We only
No. This was fantastic, and I really enjoy the diagram. To break down exactly what the model is doing. It's great.
Can you make the font larger? It's a little bit tricky because if I make the font larger, all the boxes get larger, and if all the boxes get larger, and it doesn't fit onto the screen anymore. And so, so you can make the whole image larger, but you can't really make the font larger. As you see here, there's not a lot of space. So I'm trying to compress the diagram a little bit more. That's sort of work in progress.
Yeah, that's interesting.
So I don't know. You said you don't have a lot of time anymore, but
yeah. If you have one more thing that you want to show, just feel free to go through that.
Yeah.
Yeah, I really would like to, because there's a thing that a lot of users struggle with, and that we made so much nicer. Because so this is what I just showed. That never happens in the real world. This is never what it looks like. No one gives you nice, clean data that's all floats. So here I have an example. I'm going to go through this more quickly for time's sake, but that's like customer churn in for telecom company, and you can see here most of the variables are categoricals and strings, and there's a couple of continuous, and the goal is to predict whether the one churns or not. I do the same thing, split it into X and Y. So now the thing is, there's two types of variables, continuous and categorical, and usually you want to do different pre-processing for that. And so what I'm doing here is I declare which ones are the sort of my knowledge of looking at the data frame and knowing about the domain. I know which ones are the continuous ones. And what I'm going to do is I'm build this column transformer. The column transformer will use different transformations on the continuous and the categorical columns. So I say here, for the continuous columns, I want to scale them and I want to impute them. And for the remaining columns, which are the categorical ones, I want to use one-hot encoding. And what's new in SciKit-Learn 0.20, I think, so it's been out for like half a year at least, is that there's one-hot encoder can do string variables.
Ah, neat.
And so So that's much nicer, and that's sort of a pattern that's been out only for like half a year, but that everybody should use all the time. Yeah, the other only thing I want to show off is we now have, in the last release, an experimental histogram gradient boosting. So that's basically what other people know as XGBoost or LightGBM. And so this will be like at least 1 order of magnitude faster than the gradient boosting we have right now, and competitive with like things like LightGBM and XGBoost. And that's Nicholas Hook from my team who implemented that.
Awesome. Yeah, that's really cool. Yeah, great. Well, I think thanks for that demo, Andreas, and we'll yeah. So we're going to now continue on with our roadmap discussion. So these are all of the places where SciKit-Learn is going or hoping to go, and in places again where SciKit-Learn would be very interested in taking new contributions, either from either code contributions or potentially looking for funding for these particular roadmap items, and sort of the general landscape of where you can jump in and help out if you're interested in doing so. So again, this will be very conversational. So Andreas, what are some of the places? What are some of the items on your roadmap? What's up and coming?
So okay, let me also reset this. So I'll start again with my pet peeve. Let me quickly reset this kernel.
Yeah, I think this will be fun because there's some demos, I believe, in the roadmap.
Yeah. So this is a thing that I'm working on right now about feature names. So as I said, right now, SciKit-Learn basically discards all the information pandas provides, and ideally, we would not do that. In particular, the identity of the column names is quite important. So if we go back to this telco example that we just did about customer churn, okay, so we did all this pre-processing. So let's say after the pre-processing, initially I had like 19 columns, and afterwards I have 46 columns that are the pre-processed data. But what are these 46 columns? Like if you build a model and your model tells you, oh, column 15 is really important, you want to know what is column 15.
Right.
Right now in Scikit-Learn, that's not possible really, or it's very hard to do. And I think that's ridiculous. And so so the output of the pre-processing is a NumPy array, which it's going to say a NumPy array for at least the intermediate future. But what I want to be able is to be able to give the user some input back about what these things mean. And so here, this is so this will not work on master even. This is a local branch here where you can see what what I call column names, where you can see what each of the columns mean.
Right.
And
yeah.
So this yeah. Go ahead.
Oh yeah. So it won't be the case necessarily that if you put in a pandas data frame, you'll get a data frame back out, but you'll get a NumPy array back out still. But you'll be able to recover some of that information and some of that data, right? And it looks like you've got categorical information, or like effectively kind of not the D type of the column, but the like the categorical or float or some of the other categories that the data actually fits into, embedded in that name that you get back out. Is that part of an API here then?
This is actually, you know, a second. I just realized, was the question about making the font larger in the plot, or making the font larger in the window? Because I couldn't make the font larger in the window. So here, basically, the continuous versus categorical, these are the two things in the column transformer that are treated differently, and that's the name that I gave. So it's because basically I'm subsetting the columns. I'm saying give. Oh, well, sorry, I misunderstood you, Mike.
For viewers, so it was the window font. So gonna do it. It's bigger now, in case you were worried.
Yeah. So, whoops.
And now it's too big for those.
for those
listening to the podcast later, the font is too big.
Too big. Yeah.
There we go.
So yeah. So these are names that I gave before, but the point is that I can know which transformation it flowed through.
Mm-hmm.
And so I can sort of recover the semantics, whereas before it was sort of completely black box. And if I want to recover what does column 5 mean, it's very, very hard.
Oh, I see. Yeah.
So, I mean, the obvious extension would be to return pandas data frames, but it's not entirely clear if that's the best thing to do. But it's also something we're definitely actively thinking about. I mean, so for these roadmap items, it would also be great to get feedback. So one of the easiest way to contribute is to tell us what to prioritize and what interfaces would work best for you. That's only second to giving us money, which is the best way to help.
Well, money is one way of telling you what people value too.
Yeah.
That's true.
Yeah, that's in an economic sense. But yeah, that's really an exciting roadmap item. So, what else is up on the table here?
Generally, better treatment for categorical missing values.
Mm-hmm.
So this is somewhat related.
So how is it handled right now?
Well, I mean, SciKit-Learn does things very explicitly, so you have to tell it very explicitly what to do with what. And this is probably the way it's going to stay, but we want to make it easier to do certain things. So actually, this is something that was done pretty recently, so I think this is only in development version, might not be in the release, that if you have a data frame where there's categorical or where there's string and integer data and you want to replace the missing values with the string missing, in the previous version, this just raised an error because you need to be careful about the D type.
Oh, I see. Yeah.
And so some of the things basically just didn't really work. There's also right now the only way to work with categorical data is basically to do one-hot encoding, but Nicholas is also working on putting support in the gradient boosting, and other people are working on putting it in the other trees to directly work on categorical data, which would be nice. And also, actually, Nicholas is also working on directly working on data that includes missing values.
Right. Yeah, that again seems like a great place for folks to contribute and help out.
Yeah. Also, well, generally for this, so this gradient boosting stuff, I think it's really great, but it's also very new. So if you want to give it a go and test it and give us feedback, that would be tremendously helpful because it's basically, we based it on light SVM, but it's a from scratch implementation in a sense. And so the more people that try it, and the more people that give us feedback, the better we'll get.
Right. Yeah, sort of the more use cases you have available, the better you can design the algorithm before it fully hits. So yeah, that's always good advice. Are there a lot of folks who are using the development version of SciKit-Learn out there, or is there an on-ramp for that that's more difficult than for some other projects?
Again, this is open source, so we have no idea. And so we have nightly wheels. So you can just pip install. So there should be no on-ramp whatsoever. But people are lazy, so I don't think people do this. So what we found is that we usually do a release candidate, but we never get feedback for the release candidate. Or like we get very, very limited feedback for the release candidate. So basically everybody waits until the release and then we see all the bugs.
Right. You fix it in production.
Yeah, because people have things to do, you know.
Yeah.
They can't all be like beta testing all the open source projects, but yeah.
RCs are obsolete, says Ralph. You're not wrong, Ralph.
But also he said it with a sad face.
He did say it with a sad face. It's a long live RCs. So what are the other roadmap items that we have that we can look forward to for SciKit-Learn?
So maybe a little bit less. Well, let me go to something less technical at the bottom.
Okay.
We're working at with the team and with some people in Paris on doing more things for model diagnostics and plotting. So again, this is towards opening up the black box and giving the user more of an idea of what's happening inside the model. And it helps you to build better models, helps you to validate that your model actually works. And so things that we're working on right now are partial dependence plots. They're actually a new version of the partial dependence plot in the latest release. And Thomas is working on permutation importance right now. So these are ways that tell you here. In this plot, you can see for a neural network, an NLP regressor on the California housing data set, how the house prices depend on features of the data set, so the age of the house, the average occupancy, and the average number of rooms, and the median income. You can see that in California, where the median income is high, the house prices are higher, as you might expect.
Right.
But these are things that, if the model is very complex, like a neural network, you can't really see that otherwise. So you need to have additional tools to figure out the behavior of the model. And so the partial dependence plots and permutation importance are two ways you can inspect the model. We also want to make it easier to plot stuff. Right now, there's basically no plotting in SciKit-Learn. And so you have to write a lot of boilerplate code whenever you want to look at anything. And so we're working, in particular, Thomas is working on making that a lot easier and having more sort of out-of-the-box plotting.
Right. Yeah, that introspection is just so important to be able to develop an intuition about your models. So, in particular, are there areas in the sort of broader make plotting better in Scikit-Learn that you think folks could specifically jump into, or are there, what's sort of the lay of the landscape? Is it pretty general right now, and there's just a couple of things that have already been done, or?
So I think right now what we need to do is we need to lay a foundation for this a little bit. We haven't entirely established the API that we're going to use, and Thomas is working on that. Once that is done, which is hopefully in the next couple of weeks, then there's like a pretty wide variety of things that people can do, and that should be very easy to contribute to. But I think we need to sort of have, so right now there's nothing is merged. And so we need to get the first thing merged with the API that we want. And once the first thing is merged and we settle on a design, then there's a lot of things that people can contribute.
Yeah, awesome. Is there going to be a design document for that, or some sort of enhancement proposal, or is it just, it all happens in the issue?
So we do have a formal process for enhancement proposals. I can't say, so it's hard for me to say on the top of my head if this is something that requires an enhancement proposal, because it's a different kind of thing to what we usually do in Scikit-Learn.
Right.
But so there probably will be an enhancement proposal, or like at least some short form of it to describe exactly what we're going to do.
Yeah. Yeah, that sounds great. Are there other roadmap items you want to cover?
Yeah, I mean, there's one that I'm excited about that I have up here, which is basically there's a lot of stuff about doing parameter tuning more efficiently, in particular in pipelines and with complex models. A couple of years ago, I started a hack with Matt Rocklin that now became, after him and other people put in a lot of work, DaskML. And that's basically a tool to integrate Dask and Scikit-Learn. And so here is an example taken from their website. And basically you have a modeling workflow for working on text data, where you do a count vectorizer, which is like feature extraction for text. Then you do like a rescaling, like a TF-IDS transform, and then there's a classifier. And so and now we want to tune the parameters of this pipeline on some data set. And if you do this with SciKit-Learn, what it will do is you have one parameter setting for the first one, 2 for the second one, and 3 for the last one. So it'll create all possible combinations. So there's a brute force search. It'll have 6 parameter settings, and so we'll run the algorithm, or it will run the cross-validation 6 times independently, which is sort of what's chosen here. You have the training data, you have the 6 pipelines, they run independently. However, the first step for all of these 6 settings is the same. So it does the same work 6 times for the first step, and then there's only 2 variants for the second step, so we'll then the 2 versions 3 times each. And so you can actually easily reduce this if you know all the things that are happening. And so what DAS does is it computes the actual graph of things that need to be done. So it's kind of ridiculous that we do the first thing, but because of the infrastructure, it's kind of hard without using Dask to do the right thing. So the question is a little bit, are we going to rely on Dask, or are we going to find better ways to do this within SciKit-Learn? There's one way you can already avoid some of this work in SciKit-Learn by using caching and pipelines. The problem with caching is that, you can't parallelize, because if you do the top here, and you cache, ideally you run the first thing, and then you run the second thing, and you realize you have this already computed. But if you do parallelization, you might start off the computation in parallel of the same thing multiple times.
Right.
The other thing is that to do caching, you need to hash the input, and if the input is a big NumPy array, the hashing might take longer than a computation.
Right. Yeah, so this also helps distribute the job as well.
Yes.
It's not just the parallelization aspect. So
yeah,
that's really cool, actually.
Yeah.
And so I mean the Dask solution is great, but it's also like slightly hacky, because Dask needs to like redo some stuff in SciKit-Learn, because Dask is not integrated with SciKit-Learn, and so there's some edges we need to smooth over, and we need to a little bit to decide how we're going to do this and how much you want to integrate Dask and SciKit-Learn.
Right. Yeah, no, that's a really exciting development, actually, and I'm sure another great place where people could contribute either funds or code to help out that effort. So, David, are there any questions that you have for Andreas?
No, this is all very, very interesting stuff, and it's great to see the work at eliminating unnecessary interim work that you showed here. This is really cool.
And Andreas, anything else on the roadmap that you want to talk about real quick?
Real quick. I mean, there's some more things about making parameter searches more efficient, like successive halving that Nicholas is working on right now, and working with one starting. Maybe I can actually explain this here. So basically here, I said this is the good way to do it, was my conclusion. But actually, if you change the parameter of the SGD classifier here, you could reuse previous computations. So actually, you could probably do all the 3 ones here at once, or at least you can compute this in much quicker time if you reuse previous results. And that's also something we're working on.
Right, sort of removing temporaries kind of idea. Yeah, and deduplicating effort. So, that all sounds great. Again, like these are all places where folks can, jump in and help contribute either in code or in funds, or even just in giving feedback, which and download those nightly wheels and the RCs.
Yes, please do. Another thing was, it's great to contribute, and it's very easy, is docs. Either help us improve the docs. We really care a lot about docs. Also, tell us where our docs are obscure, because a lot of us have PhDs in machine learning or related fields, and we've been working on this project for like 7 or 8 years. So it's very hard for us to take an outside perspective. So if you come to this project and say like, oh my God, this is completely incomprehensible and terrible, please tell us, because we don't know. And then you can help us either rewrite it or tell us what to improve.
Right. Yeah, that's a great point for all projects, and also SciKit-Learn. So
that's a great attitude too.
Yep. Well, at this point, we're going to go ahead and move on to our Q&A section. We've got a number of questions lined up here. So Travis asks the first question, which is, how do the SciKit-Learn developers see SciKit-Learn's relationship to other libraries like XGBoost, TensorFlow, and Torch? Is there a clear dividing line between what will be in SciKit-Learn and what should be in other libraries?
That's a great question. So you mentioned XGBoost and also deep learning libraries. So for the deep learning libraries, it's very clear that we don't want to add GPU support to SciKit-Learn because A, it's a pain, and B, it actually requires writing stuff from scratch. Also for deep learning, you basically need a framework to do automatic differentiation. And for these two, and we don't really want to deal with this. Also, there's giant communities behind both TensorFlow and PyTorch, and they have like industry backers, and I think they basically they have this covered, and we don't really want to work in these areas. We have enough to do just doing what is now called classical machine learning, even though it's newer than the neural networks. And XGBoost is slightly different. It's an interesting case because like people ask us, why don't you include XGBoost into SciKit-Learn? And the reason is that we don't really like to wrap stuff. So XGBoost was written in C++, and I don't want to maintain someone else's C++ code. But what we basically did is we re-implemented some of the features of XGBoost. There was the histogram gradient boosting that I showed earlier, because this is something that is really, really useful and a lot of people are using. And so we have our own version of this now, with the hope to make it more accessible to people. But the reason to rewrite it is that now it's in Python, and also the person that wrote it sits next to me, and so I have someone to maintain it. It's going to be very hard for us if someone reports a bug to XGBoost in SciKit-Learn. If we don't have anyone that is very familiar with the code base and the code is in C++, it's going to be very hard for us. So more generally, we have pretty clear guidelines on what to include, and basically anything that is clearly widely used and useful, like XGBoost, if there's an algorithm like this, we would like to include it if it's feasible.
Excellent, thanks.
Oh, Ralph Gomers asks, when will we see SciKit-Learn 1.0?
Wait, who asked that?
Ralph Gomers.
Oh, Ralph asked that. I thought maybe it was Thomas that is trolling me. But,
no, just Ralph.
No, so it's Ralph is trolling me. That's fine. I can deal with that. I mean, there's some things we want in SciKit-Learn 1.0, and there's different people that want different things in SciKit-Learn 1.0. And you can go on the issue tracker and look at the issues and that are tagged with 1.0. And there's the problem is that some things that get very cool. For example, once I'm on some of them, I'm less keen because I think they bring a lot of complexity. And so as long as we haven't really decided what are the required features, it's very hard to release 1.0. And so I hope we're gonna have something that I'm happy with in like the next year or two. But so that will include the things that I talked about. So none of the things that are requirements for 1.0 are any of the things that I talked about in the roadmap, FYI. So right. The roadmap, according to me, will never lead to 1.0.
Yeah, you're always halfway away from it. So Heysoon asks, do you have any plans for translating SciKit-Learn's guide and tutorial docs?
No.
Okay.
I mean, okay, wait. I guess the answer is the SciKit-Learn project will never do it because it's too much work and we already have too much work already. If someone else wants to translate the guides, they're very welcome and it would be great. But the thing is, the SciKit-Learn developers and the maintainers already have so much to do that it's not really feasible for us. If someone else wants to do it, please go ahead.
Yes, sounds like Sounds like one of
has
the
been thrown
roadmap
down.
items potentially. So yeah.
Travis Oliphant asks, what is the attitude in the SciKit-Learn community towards pandas support?
That's a good question, and it's ever changing, and it's a question on who you want to ask in the SciKit-Learn. Well, okay, the SciKit-Learn developer or user community. The user community is also depends which part of the user community. So I talk a lot about with the data science oriented people, and they breathe pandas, so everything is pandas to them, and so they definitely want better panda support, which is also why I'm pushing for that. Other people that are more on the scientific side, they don't really use that pandas that much, and they don't really care that much. So, and it's very hard to say. SciKit-Learn is definitely used a lot in both communities, and you can't really weigh one community against the other. One thing that was actually discussed seriously at the last sprint was, should everything be a pandas object instead of a NumPy array in SciKit-Learn? And actually, I think the answer might be no, because, but I'm also not sure. For example, if you have the coefficients in the linear model, they're like a linear algebra object, and so it makes more sense for them to be a NumPy array, but also you want to have the names of the coefficient they correspond to, so it would be nice to have some annotation. So actually, I think what we really would like to have is probably some more annotated version of NumPy, so maybe X-array, but maybe also not X-array, so it's a little bit unclear what exactly the requirements are. Another very important point here is, if we want to implement anything, then we need C bindings or Cython bindings. Pandas has no C-level interface, so Pandas 1.0, basically, we cannot implement anything on top of Pandas 1.0. We might be able to implement stuff on top of Pandas 2.0 if that ever comes out.
Yeah, well, a lot of trade-offs there. So Yvonne asks, does it make sense to have a PyData CI, continuous integration, that will try to test some libraries like Pandas, NumPy, SciKit-Learn when one of the libraries is updated? Sort of a generic CI service.
So whose CI? Whose tests do you run? Like, it's. I mean, Ralph said it would be great to have that, but it's like, but who's going to do it? Right. So that's how I read him. So what we do, we use the reason why I push for us having nightly builds is actually to have other people use our nightly builds in their CI, because that's what we do to NumPy and SciPy. So we use the NumPy, SciPy, Cython, and what did I forget? NumPy, SciPy, and Pandas dev builds, the nightly builds, in our CI, in our nightly builds. So we see if something breaks before anyone releases. And so I wanted for us to provide nightly builds so that any downstream project from us can do the same for us. And so Ralph says apparently for them it's very useful, because if they do something in NumPy or SciPy, we complain if it breaks our stuff. And that's clearly, they want to know that, right? And so us providing nightly builds, or them providing nightly builds, is a service to them, because it means we can test their code against our code.
Right.
And so right now, I guess it's sort of this it's basically the downstream projects test the upstream against the upstream projects, which is feasible, I think.
Yeah, that makes a lot of sense. So.
Alex Williamson asks, speaking of parallelization, in the scenario when there are multiple components of a pipeline that accept n jobs argument, do you choose one component to set n jobs, or set across all components?
I think the right answer is to use Dask SciKit-Learn and build the graph, and then do n components on the graph. Because, I mean, otherwise you're just parallelizing doing the same thing over and over again.
Yep, that makes sense. Well, it is now time for our world famous rant section, where we each get a 15-second 15 seconds to rant about whatever topic we so choose. Andreas, it is your soapbox.
All right. 15 seconds? That's very short.
Yeah, sure.
Okay, I think programming is terrible, and we have no idea how to do programming, and it's really the worst thing in the world. I think most programming projects fail still. Most commercial programming projects fail still. And if we build houses like we build programs, houses would fall down all the time, and it's terrible. And we should really fix it. Was that quick enough?
Certainly,
yeah.
David. It's your soapbox.
Assume positive intent. I saw this suggestion recently and I really liked it. A lot of disagreements start and mutual mistreatment start with someone failing to assume positive intent. So Bill and Ted had it right. Be excellent to each other.
For my rant today, I'd like to say, why are weddings so expensive? It's officially wedding season in the United States, and it's obscene the amount that people spend on these events. The upcharges for a presumably once-in-a-lifetime event can end up indebting newlyweds for decades. Unwedded myself, I'm happy to give this advice. Go to the courthouse with friends and family, and then go get a nice brunch afterwards. That's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including SciKit-Learn, you can find all of the project roadmaps at quansight.com/projects. Andreas, where can people find you and SciKit-Learn?
So people can find me on Twitter as amullerml. They can find me at Columbia if they want to come chat with me. They can find SciKit-Learn at scikit-learn.org. Obviously, there's a Gitter channel. There's a mailing list. There's also on Stack Overflow. That's a great way to engage if you have questions. There's like lots of questions, a lot of good people answering questions on Stack Overflow. Another thing that I wanted to mention is I recently published the lecture series I gave at Columbia on YouTube. So if you want to learn more about machine learning, you can find my lecture series. It's like a graduate level class on YouTube. I have a new project called Dabble that's all about automating all the boilerplate from SciKit-Learn and make everything much easier, nicer, and give you nice pictures.
Amazing. Thank you, Andreas. Well, join us again next episode for a graphic discussion on matplotlib. Bye, everybody.
Thanks for coming.